Hello and welcome back to Compiler Programming. In the last video, we did this nice refactoring where now we have C macros that wrap our builder functions to make the syntax look something at least resembling a proper programming language. And we applied this change to all of the tests. Most of them I did on video, and then the final two were done off video. And when I was doing it, I also noticed that we have this quite awful construct here to handle the loops. There is to do about this, and in general, loops is not something that we really have readily available in the language. So I thought this is what I will fix today. And additionally, when you're talking about loops, you need to support a couple of constructs that are very common to them. So to give a bit of idea, what I will be working on is this form of the loop, while true, and then you do stuff. And the reason is that this is the most universal option, because if you want to turn it into a while with condition, then you just add this condition here, right? And you say if blah blah blah, like so. Or actually, more precisely, you say if not the condition, then you break. This is the way to, this will be the same as, so if you say we have some condition, right? And we could either put it here or we could do it like this, and it will be exactly the same. And then our body will go here. So this is like while condition do something. And then we also can do while, which is sort of exactly the reverse of that. You add a condition at the bottom, and if the condition is false, you break and you again exit out of the loop. And if we think about that, that means that we need to implement at least these two constructs. One is while true, which is in reality just kind of while, you don't need any condition here. And in other languages like Rust, I think, has a special loop keyword. So this is what we're doing. And then we need to sort of generalize this break stuff, because this is what we are doing here, but in a not very nice way, right? So this stuff here, if less index, blah, blah, blah. Actually, this is not exactly what we are doing. This is the version that, so it's even more straightforward, like assembly version that says if that looks like so. So if I want to be really like pedantic about what is happening right now, we have some label, and they say if condition go to loop. Like this stuff here is what is happening right now. But this version is gonna fall apart. Like this is only the do while version, but if we also want to have another one and we want to support breaks, we need some more high level constructs, as I mentioned. So that's enough talking for now. Let's try to figure out how all of that will look like. And I think we can sort of look at how our if is defined and try to match that to the loop functions that we want. So define loop. For now, I will just do this and see what we want to do. So if is defined by encoding a operand and then doing a jump instruction that will jump over the thing. With the loop, we want something similar, I guess. We want to have a way to say, I want to jump to the end of this block. And I guess the more similar version of this would be what function builder has, where when we say return, we want to jump to the end of the function, and not something like this. So maybe a better thing to do would be for us to go here and remove this stuff for now, because it won't compile anyway, but it's a nice documentation for us to figure out what to do. And I want to function return patch. Yeah. So this is no longer function return patch. Now it's going to be jump list or jump patch list. And we are gonna do it's like so. We're gonna have put it here. There's gonna be a bunch of errors when we try to do this. Okay, 100 errors seems a bit too much, so maybe I should do it first manually and then figure out. So like so, like so, like so. Okay, and that's about it. It's always impressive how out of like 4 places where I needed to replace identifier, C managed to make 100 errors, but oh well. We also probably want to now extract this functionality where we say doesn't need to return really anything. So let's say void or no, jump patch list make jump patch and it does this stuff. Actually, it doesn't even need to, it needs to have a builder, and it says return patch. So we need to pass it the function builder. That's good. And now we are ready to say, actually no, we need to pass 2 pieces of information now. One is the builder and another one is jump patch list next. And here we say next. So now we can do make jump patch builder return patch list. Okay, let's check if it builds. We also check if we haven't messed up anything. Everything is great. Let's continue. So this is a way for us to make new one of these. And for the second part of it, we also need a way to like iterate over all of them and do stuff. So where is our function end? function and where you are, come here. Okay. Maybe we should move this stuff up a bit. It will look nice here. Okay, function end. And function end is the thing that deals with these patches. So we say, what should we say? We say resolve jump patch list, and it doesn't actually return anything to us. It's just a thing, and we need to pass it a builder, yeah, and a list. Okay. Now, what it will do is it will do this stuff instead of directly referencing builder return list. We need to resolve jump patch list of builder and build return patch list. So that's good. And let me think about, so we say jump patch and patch. Good. Let's see if we haven't messed up. Just one more step. And let's check it out. Okay, so this was just a small detour in refactoring to prepare this functionality to be used by other places. And in particular, it needs to be used by our loop that we started to think about. Okay, so let's think how it will work. So we say loop, we will likely need, same here, and we will always at least have one jump patch, because that, I guess, will we not? No, I guess if the thing goes through, then it will not. Before making a macro, I guess I will try to make it manually so we know better what to encode, because it will be slightly different from this version. I think so. This is our loop, and inside the loop, this is still inside the loop, and this is also still inside. So yeah, this is the whole loop. I sort of misjudged what is the loop body, but this is the whole loop body here. Okay, so we mark the place where we will jump to the top. So we basically add a pointer there, or like a label there. Then we, this is just supporting thing here for the main body, and this is the interesting part. This is also not the interesting part, and this is not the interesting part. So interesting thing is patch jump. Instead, so we need to say, we need some way to say break in the loop, before we continue with our implementation. And the break would look like what? It's in here, or in here rather, we say jump patch list star jump patch list is nothing. And if we want to break, we will sort of add to this list. And now we say jump patch list, yeah. It will be what? Say while resolve and patch list of builder and the list. And we also actually need to have a list here, because if there is no break inside the function, that means that our loop will go forever. So we, interestingly enough, kind of have one of those checks that, for example, Clang has, where you try to make a loop that has no exit, and we're like, oh, well, you're trying to do something that's not good, and we are getting this for free. So we can say assert jump patch list, right? And this assertion is checking that need to have, or rather do it like this, if not jump patch lists assert not or I mean, we do want infinite loop at some point, so maybe we shouldn't make this assert. We should just say if there is a patch list, then do this. Because for some applications, you actually do want an infinite loop that is the event loop, I guess. I don't know. Let's not worry about this for now. And now we slightly change what is happening. So this patch jump to IP, which is part of the main loop body, like what I showed you here. So this is, again, this is the main loop thing, where we have loop and we say go to loop. Like this is also, so this loop is this stuff here, and then go to loop is now this. It's like maps really one-to-one. But now we need to add a break, and break is literally just saying, okay, here's another label, and if not condition, then go to break. So this is how break works. And continue is actually also the same thing here. So like you can imagine that, because you can always put a continue at the end of the loop and it doesn't change anything, right? It's useless, but it doesn't really hurt, except you have extra instructions in the loop for no good reason. So these are two forms. You have loop start, and you have, maybe we can call it loop end. And this is all what loop is. This is break, and this is continue. Let's say break, break, and continue. This is all that we need to implement. Let's comment this out for now, and we don't need this version because it's more high level than what we would like at the moment. Anyway, what I was saying is, now this needs to be an inverted condition. And this means that we need to implement not. I'm actually not not certain how is the best way to do it. Basically, not is our is very similar to the function that we already have, which is somewhere on here. Yeah, so it's sort of the inverse of this function that says if the function returns 0, then it is gonna be 1, and if it's otherwise, it's 0, because all non-zero values are considered like truthy. So that means that if we inverting, we need to do it that way. For now, I guess I will do it manually and just change it to more. And less is also was the wrong name for this, because what it should be called is no, less was correct. Less and greater. Okay, so if greater, this is our break, and this break is gonna be jump patch list is make jump patch of builder and jump patch list. Okay, so now it will fail because we don't have greater in our instruction stuff. So let's deal with that. It is gonna be inside of set stuff. So you have set Z, set L, and I imagine what we want now is set G. Okay, so set G, and set G, and even more, set G. But of course we need to actually know what is happening there. That means we need to go here to set CC, search for, or we don't even need to search, this is our set G stuff. And set G is 0F, 9F. Okay. Good. Now we need to go to where we have less and change it to also have greater. And change here. Good. Let's think. Yeah, we don't know what compare greater is. We need to add it here. Now we can build. So let's get rid of Firefox for now and see what we are dealing with here. So now we have did it in, make jump patch. Yeah, that seems good. And we are off. Okay, let's see if this still works. It does indeed still work. We can also take a look at how it looks like in assembly. And like so. This is a bit too big. Really, like this is fine. I get some feedback that previous video it was hard to read the text, so I bumped my UI scale a bit and text everywhere. Hopefully it's better now. Now let's take a look at this stuff. We go here, and then we want to go into this call. Okay. So yeah, this is exactly what I thought I would have, but just to clarify what is what here. Get away. We have this comparison, right? And then we do a jump equals to here. So this is like if the comparison fails. And then if the comparison succeeds, we go to the next instruction, which is this jump. This jump is the one that is break, if you remember. So it's this jump. And this jump takes us to the epilogue of the function, which is this add RSP that restores our reserved stack space and returns, of course. And then as said, if condition fails, we go to this jump, and this jump is a jump for the loop, which takes us all the way back to the beginning of the loop. And this is fine. Actually, now we need to slightly change the code. It's interesting why it succeeded, because we are doing something wrong now. We are doing this. Actually. Yeah, we were doing something wrong before. We were doing this comparison way too late, but now we can actually get rid of this to do, because what we can do is move this check all the way over here and make it at the beginning and turn it into a proper like while loop. So increment pointer, increment index operand. Yes. So to clarify, what is happening now is we moved like I to here, right? And this I is our index. So this is index plus plus, or to be precise, plus plus index. So, and here goes our body. This is how the current loop looks like. This is if, like so. Good. So with this, I believe we are ready to start figuring out how to turn this into something more reusable. Let's take all of this stuff and go to where our define if is and think about how we're gonna do this. So we don't need any of these things or these things, right? And we don't even need this increment, because that's something that the user code has to deal with. And we are left with relatively nice way to deal with stuff. This if jump hatch list resolve, I think we can go to the place where we created this, and actually we don't even need this if, right? Because it's a while loop. That means that we can just do it like so. And this actually simplifies our life quite a bit. Okay. Now we need to figure out how to turn this into a nice and shiny for loop. So we do loop, there is no condition, because we can't really make this for like a for loop or a while loop from C, because this macro then needs to accept a block of code, and this is simply not the capability that we have right now. So if we wanted to do a while loop, we would still have to be something like loop head and then loop body or something like this. Maybe it's something we will do later on, but for now, this is a version that we're going for. Okay, loop. We need to store this and we need to store this. And yeah, we can use the jump patch list for the condition here inside, but I guess we'll need to have a struct type def struct loop builder, even though it's not really a builder, but we needed it not be named loop. And this thing will just have loop, or since it's a builder, we have a start IP, and it will have jump patch list, which is of type jump patch list star, like so. Okay, now that we have that, we can start writing out our loop, and we say loop builder loop builder. Okay, and then we need to have a condition here, and as I mentioned, our condition for this will be actually this needs to be like this, or rather we do need to put the instruction pointer in here. Okay, let's not be lazy and do this the right way with some indentation and such. Okay. IP is this, and then jump patch list is also 0. Okay. Now we need our condition, and the condition will be loop builder jump patch list, or rather not loop builder jump patch list. And as the last thing that we do, we will let me think for a second. So yeah, we can just this is a bit unfortunate. Or actually no, we can take this thing, patch jump to IP. No. Actually no. I'm being slightly wrong. We do need to have a different condition here. So let's just say bool done, and let's let's just create a helper function that will deal with this for us. That will do make loop end, and it will accept a pointer to loop builder. Okay, and this thing will do this, all this stuff at once. Is this fine or not? Yeah, I guess that's fine. And it will say loop done is true. Now we can change this condition to be just done. And here, instead of this patch, we say make loop end of loop builder. That seems fine to me. Let's first see if that's at all builds. It does not. So where did I mess up? Yeah. So the first thing first is it needs to have a function builder here. So it's gonna be like this and like this. Okay. Instead of loop start IP, it should be loop and loop. Okay, this is better. Now, what is wrong with the for loop? Builder undeclared identifier. Oh, yeah. Macro syntax always trips me up. So I forgot the slash here. Okay, it shouldn't change anything because we are not actually using this loop, but we can do so right now and hopefully make our code look just a tiny bit nicer. Before we do though, we also need to have another thing here, which is, okay, let's go back to the loop, and we need to add break to the loop and actually continue, well, since we are talking about this as well. So continue is, we can do it like this, I guess. Yeah. So that it looks the same as in C. And continue does this stuff. So it's gonna be make jump of builder and then a loop builder start IP. Okay, that's continue. We can remove semicolon, so it forces us to use a semicolon. And then the break one is also rather simple. It is this thing that says, so in our case it means loop jump patch list is make jump patch list of loop. Okay, And this is our break. That seems nice. Okay, that's still built, but we are not using it yet. So let's use it. Say loop. And we also don't need the, I guess, the braces here. So let's get rid of those as well. It's gonna be like just loop, which is nice. And we can copy this code together with to do if greater index than this, and now we can say break, and otherwise we do stuff, and we don't need this continue anymore. So we now can, we don't need this jump to IP as well. We take the main code of the loop and put it right here. Okay, and get rid of this stuff, and get rid of this stuff. And before we do, we can look at that it looks quite close. So we have this if not condition break, right? This is this thing, and then if we go all the way, we don't see the continue, but we can also put an explicit continue, which we will do once we test that this version actually works. Apparently I screwed up something. Incompatible types from loop builder to function builder. Yeah. I need to actually have it here. This is better. Loop is undefined identifier. Yes, it's very much undefined. Okay. We can build. Let's try to run tests, and the tests are passing. So now we can try to do the promised continue in our stuff. So let's go back here. And as I said, there should be absolutely no difference if we put a continue here. But you never know until you try. First of all, continue apparently also has some bugs, which is not great. So let's fix that. It's gonna be like this. Looks good now. Good. So this is continue. Let's check if this still works, and it does. If you look at the disassembly now, we will see a redundant jump from that continue, but it's perfectly fine for it to be there. It's just a bit inefficient, but who cares? We are just wasting like 5 bytes and not even any CPU cycles on that, so I definitely don't care that it's there. And you can see this is what I'm talking about. These are the two identical jumps, that one of them comes from our loop code, and another comes out of explicit continue. Cool. So now this can go away, and we have a way to do simple loops, which is really nice. With that, I think this is all for today. Thank you very much for watching, and hopefully see you next time.